We can think of the network like a conveyor belt in a factory, but the machines are conditional. So, if Absalom is present, then the machine is turned on and the White Queen can be produced. But if Absalom is not present, then the machine is turned off and the White Queen is not produced. Now let's go through the conveyor belt using the functional network. Since Absalom is present, machine 1 can turn on and the White Queen is produced. Since the White Queen is produced, machine 2 gets turned off, and therefore the Red Queen is not produced. Therefore, machine 3 is turned on, and Alice gets produced. Since Alice is produced, machine 4 gets turned off, and the Jabberwocky is not produced. Absalom is able to activate the transcription of the White Queen because Absalom protein binds to a transcription binding factor binding site upstream of the White Queen. Now, what if there is a single mutation so that the White Queen was not functional? Absalom would still be present and turn the machine 1 on, thus producing the White Queen. But the White Queen isn't functional, so even though it is produced, it cannot turn off machine 2. So, the Red Queen is produced. Since the Red Queen is produced, machine 3 gets turned off, and Alice is not produced. Since Alice is not produced, machine 4 gets turned on, and the Jabberwocky is produced. Now, if there were a double mutation so that Absalom and the Red Queen were both not functional, what would happen? So, since Absalom is not functional, it cannot turn on machine 1. So therefore, the White Queen is not produced. Since the White Queen is not produced, machine 2 gets turned on, and the Red Queen gets produced. Since the Queen is produced, machine 3 gets turned off, and Alice can be produced, which then turns off machine 4, so that the Jabberwocky is not produced.